Hey guys, good morning. So just wanted to quickly go over the two problems that I asked you to do yesterday on the worksheet. The first three I had already gone over in the notes, and then here's the other two. Here's numbers 4 and 5. So I purposely only left you the two problems because I knew they were different. I knew it would be a little bit of a challenge. So I just wanted to kind of do that, and hopefully you invested some time in it, and you eventually got the answers. As I mentioned in yesterday's video, we're using different solving methods. And while yesterday's solving method was mainly factoring out a greatest common factor, here it was factoring trinomials. So with 4 and 5, we had cosine 2x. So we had to use our double angle identities for cosine. And we have a few different ones, right? When we verified, most of the time we use this top one here. Or when we just used them and expanding them out, we use that first one. But I would suggest using one of these other two, depending on the problem. And in number 4, since both of the terms we were given were cosine, I wanted to just have cosine in the problem. So I use this one right here, 2 cosine squared x minus 1. So I use the double angle, 2 cosine x minus 1. At this point, I just reorganized and put them in different order. So I just switched the order of the cosine or the negative cosine to negative 1. Now it's a trinomial. If it helps, this is something I said a long time ago. Just ignore the cosine. Think of it as just basic algebra. 2x squared minus x minus 1. You have to factor it. All right. So these two problems were based on factoring trinomials. And double check your signs because we needed a negative cosine here and a negative 1 here. So here's what it would factor out to be. I take each factor, set them equal to 0. I'd subtract 1. I'd divide by 2 here. Here I would just have to add 1. And I think to myself, all right, which angles have a negative x value of, or have an x value of negative 1/2? And that would be 2 pi over 3 and 4 pi over 3. X, or cosine's negative in quadrants 2 and 3. Which angle has an x value of 1 and it's 0, right? It's right here. This is 1, 0, and that point is 0. It's also 2 pi, but we'll stay with 0. And number 5 looks very similar. The only difference was instead of a cosine, we had a sine. So because of that, I chose to use this third cosine 2a identity. Right? There's multiple choices here for cosine. I chose to use the last one. Why? Because it was sine, and I knew that if I took this out of the problem, I wanted to make sure it was all the same trig function within the problem. So I did that. Again, I restructured the terms. I just put them in a different order. The first term was negative, so I took that out, changed the signs. And then again, I just factored. So 2 sine x plus 1, sine x minus 1. The signs match up. I subtracted 1 divided by 2. I added 1 over. Y is negative in quadrants 3 and 4. The reference angle here would be pi over 6. But because we're in 3 and 4, it's 7 pi over 6 and 11 pi over 6. And where does y equal 1? Y equals 1 at pi over 2. All right, guys. So, hopefully you took a few minutes, watch this video today. I think it should help.